Okay, this section is over the division property of exponents. And so as you can see here, these are the different properties that we've had so far, and we've worked through them. Really, we're going to combine the first 5 properties that we talked about, and today we're just going to start dealing with them involving division. And so we have the quotient of powers property. That says that when you have the same base, and you're dividing two things that have the same base, that you can actually simplify it by subtracting the exponents. Now notice when you subtract the exponents, it is the top exponent minus the bottom exponent. We do have these disclaimers off to the side that say if a does not equal 0. That's just there because if the base is 0, then your answer is 0. Here you can't divide by 0 on the negative power property, and so we say a is not equal to 0 because you can't divide by 0. And so whenever you have a base of 0, you're really just going to have 0 as an answer, and that's why those disclaimers are there. We will also deal today with the power of a quotient property, which is just like the power of a power property to a certain extent, where you're going to bring that exponent in to everything that's inside the parentheses. You're going to bring it into everything in the numerator, and you're going to bring it into everything in the denominator. And so that's basically where we're going with things today. And so let's go ahead, let's look at a few examples today and work through there. And so let's start. I just want to make sure everyone is understanding exactly what's happening here. We have x to the 5th over x squared. That means to take x times x times x times x times x, and then x times x. Now, what's happening as we go through there is these x's, x divided by x, that's just going to equal 1. So a lot of times people say they cancel out. Yeah, they cancel out to be 1. So these cancel out to be 1. When you multiply by 1, it doesn't change anything. So all I'm left with here is x to the 3rd power, or x cubed. You look at it, we want to be able to skip this middle step so we don't have to write all those x's. You can imagine if this was x to the 55th power, we wouldn't want to write 55 x's here. And so we want to have a way of skipping this middle here. And that method is when they have the same base, subtract the exponents, top minus bottom, 5 minus 2, and you get x cubed. Now sometimes the bottom number is going to be bigger. That's okay. We still do the same thing. You have the same base, the base of x. 4 minus 7 is negative 3. Now, a lot of times, though, the directions will say, rewrite the problem with only positive exponents. And so, to write that as a positive exponent, remember, we're going to bring that negative 3, that tells you to bring it down to the bottom here, to the denominator, and so I have 1 over x cubed. A popular way of looking at this, or a way I kind of look at it, is I look at this and I say, okay, I have x's on both top and bottom. There are more x's on bottom than on top, because there are 7 x's here and 4 x's here, and then I just look at how many more x's are on bottom than on top? Well, there are 3 more, so it's 1 over x cubed there. Don't be alarmed or don't panic if all of a sudden they put numbers in here like 12 and 4 there. That's just a fraction bar there. Remember, that means division. 12 over 4, we're not going to subtract there. Remember, the fraction bar is division. It's 12 divided by 4, and that will be 3. So you'd have 3x cubed. Say you have 5 over 15. Again, we're just dividing there, and so this is just like a fraction. 5 goes into here 1 time, goes into here 3 times, and so I'd have 1, and then I'd have an extra 3 down here. So the top would still be 1, and then down in the denominator here I would have 3 there. And so that's the basic principle of our properties today, is working with that. Let's look at these properties together here. And so we got this big, ugly problem with all sorts of stuff going on. This is one thing I would say here. Whenever you have a situation like this, instead of bringing that into everything right away, look to see if there's anything in here that you can simplify. As you look here, I have 3 x's here and I have an x here. This x here is actually going to cancel out, and what I'm going to be left with is x squared. The same thing is going to happen with the y's. Actually, I'm going to have one of these cancel out, and I'm just going to have a y left. Now, I am still going to have the 8 in the denominator there, and so just to kind of rewrite this and make it a little cleaner now, what I have is I still have the parentheses. I have x squared y over, I still have the 8 there, and I'm still taking that to the 4th power. You can do this in a variety of ways. I'm going to go ahead and just kind of simplify this up a little bit. Notice I have x's in both here. I have a 5 here and 7 here, so there's more in the denominator, and to be exact, there are 2 more in the denominator, so I have that over x squared, and so those are going to cancel out there so that I have x squared on bottom. Now, this is interesting here because I have a negative exponent there. Remember what we can do with negative exponents? We can actually just bring that down here. And so when I bring it down there, I have y to the 4th times y to the 8th. I'm actually going to have then y to the 12th in the denominator there. And so I'm just kind of trying to clean this stuff up the best I can. Now, I don't like this 4 here, so since I've already simplified inside there, I'm going to go ahead and bring that through. And so remember, we have to bring that into everything. And so as I look at this, power to another power, I'm going to multiply the exponents. So that's to the 8th. There's a little power of 1 here, so 1 times 4 is just 4. So that's to the 4th. And then don't forget, you still have 8 there too, so I have to take the 8 to the 4th power as well. Now, as I go through here now, notice I can cross simplify here as I look at this. And so rolling through there, I have 8 up here and I have 2 down here. That means I have 6 more on top. I have 4 here and 12 here. Man, I have a lot on the bottom there. In fact, I have 8 more in the denominator. Now, I am going to need to eventually go through and take 8 to the 4th power. You can do that, you know, kind of whenever you want to, and that ends up being a really big number as when you do that. It actually ends up equaling 4,096. Again, when you do that is completely up to you. I'm going to go ahead and do that right now. That's 4,096. And remember, kids, you can use calculators and stuff as you go through there. And so let's see what we have. Let's multiply across the top. I have 16. I have x to the 6. In the denominator, I have 4,096. And I have y to the 8th. Now, the x to the 6th, the y to the 8th, those are fine. I'm guessing, though, that the 16 and the 4,096, I'm just betting I'm going to be able to break that down. And in fact, I can there. 16 goes into 16 one time, so I'm left with x to the 6. And 16 goes into 4,096 256 times. And so always check to see if you can simplify those fractions. In this case, I was able to. And so I'm left with x to the 6th power over 256 y to the 8th. And so hopefully you can see through that problem. I used this when I had the same variable in the numerator, in the denominator. And then I used this when I had an exponent on the outside of a quotient. When I had an exponent that was outside of a division problem, I brought that into everything. Can't stress enough, simplify inside the parentheses first, and that will help a great deal. I do want to end, as we usually do here, with just a little bit of a joke as we finish things off. And so with winter kind of upon us now, I want to talk about snowmen. And as you look at snowmen, sometimes people will use a carrot for the nose of a snowman. That's because carrots, though healthy for you, are not as delicious as bacon. You know, if bacon wasn't so delicious, you might use them in the process of making a snowman. But nobody uses bacon when making a snowman. Not because it wouldn't look incredible on a snowman, but because bacon is too delicious to ever make it outside to a snowman. And so, unfortunately, snowmen have never experienced bacon due to bacon's deliciousness. But I want to share just a quick kind of joke about snowmen here, and that would be, how do snowmen travel around? By icicle. How does one snowman greet another snowman? Ice to meet you. Have a great night, students.